Linux is based in Southern California and has over 500 locations. Linux is mainly known for its truck bed liners, but has recently expanded into industrial coatings and blast mitigation. Linux was actually created by Claudio Burton, a chemist. He found that this chemical could be sprayed on most metals, concretes, or woods, and it could protect them against abrasion, abuse, and impact. The Linux polymer protected bed liners so well that the Department of Defense hoped it could also protect buildings against a terrorist bomb attack. In 1999, the Air Force commissioned a study to look at how they could reduce fragmentation in a bomb blast. They looked at about 26 different coatings and selected Linux as their choice for blast mitigation. Fragments, or sharp pieces of a building, are the #1 killer in a blast. Over 80% of the death and destruction is caused by fragmentation. The Linux polymer is stronger than steel, but unlike steel, it's elastic, so it can absorb the impact from a bomb blast. A common building method is called infill walls. They build a rigid frame and then fill in the gaps with cinder block. Those cinder block sections can be coated with Linux. The Linux will hold it together, and in the event of a bomb blast, will prevent fragments from flying in, causing damage and death. A great demonstration is to drop a cinder block from the top of a building. What we will find is that block will break into sharp fragments and shards. This demonstrates what would happen to a building that's not coated with the Linux coating. It creates these deadly shards that would fly through a building, causing damage and fatalities. We can then take a similar block, coat it with Linux, and drop it from the same height. As you can see, the Linux block is intact. Probably it's broken inside, but the Linux coating has held it all together. We're here at New Mexico Tech's Bomb Blast Testing Center. This is an example of Linux blast-proof paint. It's 1/4 inch thick, and it took about 30 minutes to apply on each side of this wall. It's going to protect this CMU when the blast happens to stop fragments from flying into the building. This is an identical construction, CMU wall, and we expect this to fragment and fly in and strike the people and objects inside. This is the inside of the structure. We've coated this with 1/4 inch of the blast-proof paint. We've set up a scenario where we're going to simulate a terrorist attack. We've got an office setting with somebody in it, and we will see that this coating will protect the inhabitants and the assets inside the building. This is an exact duplicate of the other room. And what we'll expect to find here is this will fragment and sharp pieces will fly in, striking the mannequin and the office equipment. The explosive charge contains 200 pounds of TNT and 5 pounds of C4.
Four, 3, 2, 1.
Like the Linux wall is intact.
Yes, it survived very well.
Got complete failure of the untreated wall and some significant fragmentation, a lot of it on the outside. Let's go inside and inspect the interior. Significant fragmentation and failure in here. Lots of sharp shards and debris. The dummy itself has been decapitated. Significant damage and impact to the test dummy and the equipment.
Obviously, the whole wall has failed. Had there been a real person in here, they would have not survived.
This did precisely what we expected. Successful test.
Yes, it was.
We're going to inspect the wall with the blast-resistant paint on it. Looks like this wall is 100% intact. The dummy is still in his seat. A little bit of dust on the desk, and one drawer is partially open, probably from the concussion.
No fragmentation from the wall itself. The structure seems to be very competent. Certainly the Line-X has proven itself as being blast-proof.
With all the talk of terror prevention, Line-X is one company that is taking action to address the issue.